Right, we have talked very briefly about this in the past, and we're now going to formalize it a little bit here. We have midpoints of this triangle that we have connected, and this has a name. It is called the midsegment of a triangle. And if you look at these two triangles, I hope that you see that we've got an SAS situation here in terms of similarity. I've got my reflexive angle there, side angle side, and then side angle side here. So how do you think that DE is related to AB? I hope that you see that those two things, that this is half of that DE is half of AB, because if this is a 1-to-2 ratio, then this has to be a 1-to-2 ratio. And I hope that you also see that this one has to be parallel to that, because if these two triangles are similar, then those angles are the same, and corresponding angles would give a parallel. We are now going to prove them, because this is actually the midsegment theorem. So we're going to prove that DE is half of AB, and we're also going to prove that DE is parallel to AB. So we're going to start with DE is the mid segment of a triangle. And what that means specifically is that CD equals DA, and that CE is equal to EB. Actually, let's do this different. Let's say that D is a midpoint, and the E is a midpoint. You can do either one. Definition of mid-segment. Now, from there, I'm going to say that CD is equal to half of DA. Have a look at that. And I'm also going to say that CE is equal to half of CB. Now, I can also have said something like CD is to CA as 1 is to 2, something along those lines. A lot of varieties that I can do here. You just really need to communicate that you know what's kind of going on there. So I've got kind of some equal ratios with these two sides, and then I just need to say that angle C is equal to angle C. And this is a ratio, this is a ratio, and this is ratios. And then I can simply say the two triangles are similar, not congruent, but the reason is SAS similarity. So from there, I can easily say that DE is equal to half of AB, because similar triangles give me equal ratios. So it's got to be the same ratios as what I have up here. And then I need parallel, and the only way to get parallel is to use angles. So the only angles that I want to use are 1 and 2. You could have used the other set as well. And why are they equal? Because similar triangles give me equal angles. So I've got equal ratios and equal angles. And then those angles are special. We chose them. I'm sorry, I didn't write this correctly up here, just parallel. We chose these guys because those were all corresponding, and corresponding angles that are congruent to each other give us parallel lines. Okay, wow, done. So what does that mean? If we have a midsegment of a triangle, that the ratios is a 1-to-2, and simply that those guys are parallel. Again, we've been operating under that for a long time. We just formally proved it now. Let's look at this one here. So this one here, I have that these two angles are equal to each other and right angles. And I wanted to prove that, well, hopefully you can see that you can prove that it's a trapezoid. So I'm going to go ahead and start with my given. I'm getting lazy. Apparently I've been doing this for too long. Too many hours in a row. Okay, so I've got, that is my given, which tells me that angle A equals angle D equals 90 degrees. And those guys are supplementary angles, and they're same side interior angles, so you can say that these guys are parallel. same side interior angles being supplementary gives me parallel lines. Now, I don't want to jump ahead here, but the reality is that I looked at here, and there's no triangles that are equal to each other in this whole little spiel here. So I need to either be able to get that it's a trapezoid directly from my given almost, or I'm kind of up a creek. So I know they're 90, which gives me supplementary, which gives me same side interior, and I know that if I have parallel lines, that is enough to prove that it's a trapezoid. And I know that because that is the definition of a trapezoid. So, kind of cool.